Hi, this is Adam Griffin with the second video for this week. So this is going to be problem number 4, which deals with the Rayleigh criterion. So basically we're going to be discussing how to determine angular resolution and spatial resolution from a few given variables. So problem number 4 asks, recently an image was accidentally released from a spy satellite, and the spy satellite is known to have a mirror with an effective diameter of 2.4 meters, and the image is thought to have been taken from a distance of 382 kilometers. For this problem, assume the aperture of the mirror is 2.4 meters, and take the wavelength of visible light to be 550 nanometers. So part A is asking, so assuming that the resolution of the spy satellite is only limited by diffraction, and that means it's not limited by refraction, use the Rayleigh criterion to estimate the angular resolution of the detector. So the angular resolution is this angle right here, and it's saying that no matter the distance to whatever you're looking at, the angle between like two objects that you can differentiate between will always stay the same. So to find that, we get that our, this is from the textbook, our theta min, which is the minimum angle of resolution, is equivalent to 1.22 times our wavelength divided by the diameter of our aperture. So we plug in 2.4 meters for the diameter, 550 nanometers for the wavelength, and we get our theta min is equivalent to 2.8 times 10 to the negative 7th radians. So that is the this angle. So for part B, it's asking what is the corresponding spatial resolution of the satellite for objects on the Earth? Would it be sufficient to read the U of O logo in the end zones of Autzen Stadium? So the Autzen Stadium logo is, it's about 9 yards across, 9 yards in diameter. So in order for us to be able to see that, the spatial resolution has to be less than 9 meters. So the spatial resolution, we just plug in our distance. So down here we have theta min equals the distance from our telescope to the Earth, divided by, the S is the distance from our telescope to Earth, and D would be the spatial resolution. So the minimum distance between 2 points that we can like differentiate between when we're looking at an image from a telescope. So we can plug this in, we rearrange it, and we get that spatial resolution. The minimum spatial resolution is our theta minimum times S. So we just plug those in. So our S is our distance to the Earth, and then we calculated theta min in the last problem. So that gives us a spatial resolution of 0.107 meters. So 10.7 meters, or centimeters, pardon. And since that is smaller than the Autzen logo, we can see it with that telescope. So the answer is yes for part B. And then for part C, it asks, news reports said that the image had a resolution of better than 10 centimeters. Is that consistent with your calculation? So ours is 10.7 centimeters, and it's asking if it's saying that it's better than 10 centimeters, which means that it can see something smaller. So because ours is greater than 10 centimeters, the answer is no. So yeah, that is part C. So that is how you do problem number 4. I hope it was clear, and thanks for watching.